Okay, in this video I'm going to show you how to do a mixed factorial analysis of variance in RStudio. It all begins with your data file, so you're going to need to use a data editor like Excel to create your data file. I would first start with a column for your subject identification number. Each subject gets a different number. I'll explain this in just a second. And then you're going to have a column for your first IV. So this first IV of STEM is actually between subjects. It's a mixed design, so we're going to have different subjects in each one of the levels of the stimulus variable. So we have match, and so you'll notice subjects 100 are in match. Subjects 200 have the OS level for STEM. Subjects with 300 numbers are in the unprimed. So we have three levels here of our stimulus variable. Match, OS, and unprimed are the levels, and each subject has a different number. Now, one thing as I'm thinking about is I use all capital letters. You'll notice that I do that for a reason, because R and RStudio are case sensitive, so it's a lot easier if you have all capital letters for everything. So that's a good tip for you when creating your data file. So now let me explain this other bit. So you'll notice that there's two entries for subject 101 and 102 and so on. Actually, for all the subjects that's the case. That's because we have another IV here, which is a repeated measures IV. We're calling it item, and there's correct rejections, or CR, and hits. On a recognition test, a hit is an old item called old, a correct rejection is a new item called new. So each subject has measurements on hits and correct rejections, so you have two lines of entry for each subject. And you'll notice this is true even when we go down here to the 200 level subjects for the OS, and then we have the unprimed, the same thing is true. So that's the way you want to organize your data set. If you have repeated measures, you're going to have multiple rows for each subject each time with a measurement. So prop here is our dependent variable. That's the measurement that we're going to be analyzing. So you want to set your data file up first. Save it. When you go to File, Save As, this is very important too. You're going to save it as a comma-delimited CSV format. Now, Excel has multiple versions of CSV. Make sure you select the plain comma-delimited CSV version. Otherwise, you may have some problems importing your data into RStudio and making it run. So that's an important tip. So what we're going to then do, so now we have RStudio started. Now we're going to import our data. So there's a couple different ways you can do this. You can go over here to Import Dataset. You can go to File, Import Dataset, and we're just going to select the text-based generic one. We'll navigate to the data file, and I'm selecting the data file mixed. Click Open. This window will pop up for your import dataset. Up here, it's going to ask you to name your data frame. I encourage you to use a short, simple data frame name, because you'll be typing this into your commands, and you want to give it a descriptive one so that you can keep your data sets separate if you have multiple data sets. Over here to the right, you'll see the file that you're reading in, so make sure that's the file that you want to read in. You have lots of little selections here. Key one is strings as factors. That'll make your life easier when you're importing your data set. This is what your data frame will look like when you import it. Click Import, and your data come into RStudio, and we're getting close. So the next step, what we have to do, if we're going to do analysis of variance, I use this package called AFX. So you can see it's over here in my list of packages. If you have not installed this on your computer, you will have to install it. So you go to here to install, and then select the AFX package and install it. I have already installed it, but even if you've already installed it, you have to activate it before you can use it. So you click that checkbox, and it's going to load. And you can see you could also just type library AFX in your command console, and it would load that library. So now we're ready to use the AFX command. Okay, so now what we're going to do is we're going to create a variable for the outcome of our analysis of variance. I'm just calling it AOV1. We're going to set that equal to this, and we're going to use this ANOVA easy command. So it's AOV easy. That's from the AFX package. And the first thing it's going to ask you for is what variable is your subject identification variable. So it's easy, it's sub ID in this particular case. What is your dependent variable? That our dependent variable is prop, right? Our data frame, which you can see up here, is called data1. So we're going to put that name. It has to match. And of course, your variable names have to match. Now we're going to tell it to design. So I have a between subjects IV. This is a mixed design. So we're going to use this format. And the mixed or the between subjects IV here is STEM. So if you remember, that was different groups of subjects. Then we're going to add a comma after the STEM. And we have a within subjects IV in this case. And we're going to put that, this one's called item, in there. And that's our command. So we're telling the AFX command we have a between subjects IV called STEM and item, and it will run the analysis with those variables. Now, if you had a second variable of either one, you just insert it into the parentheses, and so you would just have, you know, a comma, and then like if your item is also, if item is also a between subjects, you would type it there. We don't have that, of course. Same deal here. If you have another within subjects IV, you're just going to type it over here, right? But we don't have that separated by a comma. We don't have that, so we're not going to include that, so this command will run. So we have our ANOVA easy command ready to go. We're going to press enter, and it runs, and you'll notice there's no output yet. But if you look up over here in our environment, it's created this object AOV1, which has all of the outcome of the analysis of variance. So there's two ways to see this. You can just type in AOV1 into the command console, and you'll see the output. So it's telling you that it's analyzing the dependent variable called prop. You have a variable called stem. There's 96 degrees of freedom. This is your mean square error is 0.01. Here's your F value. GES is generalized eta squared. And p-value, of course, is your level of significance there. You have a factor for item. And then, of course, you have the interaction. It's kind of labeled funny here, but you have stem : item is like your stimulus by item interaction with your degrees of freedom F, etc. So now the other way to see the output is to use this nice command. So if you do type in nice, and then the object, which is AOV1, that's holding our output of our analysis of variance. And then we have a couple of things that we can type in here. So I'm going to change the effect size to partial eta squared, so that's PES. And then I'm going to apply a correction, a Geyser greenhouse correction, which I use all the time. And so if you want to apply corrections, you can add that there. And then I'm also going to suppress the mean square error just to clean up our analysis. So obviously if you want the mean square, just don't include this statement. And so if we press this, then you'll see what it looks like. So now we have our analysis of variance in the output, and it's done the correction, but obviously it didn't need to correct for anything in this particular case. So that's it. If you like the video, please click like. If you want to watch more of these videos, consider subscribing. Thanks a lot for watching.